Okay, so welcome back if you were here in the first teaching block. My name, for those of you that don't know me, is Vasilios Adamos. You don't have to learn all of this, you can just call me Vas. We will be doing some cloud computing together for this teaching block. The module is supposed to have nearly 100 students. There's about 35 of you here, hence why I'm recording this. All right, what I will do today is I will explain how we will run the module, how you will be assessed on this, what the week-to-week will entail of this, and basically I will explain the first lab sheet as well, because when you come into the lab next week, so the labs are on Thursday, you will need to have a bit of an idea of what it is that we're trying to achieve and how we're trying to do it. Okay, so the first thing that you need to know is Moodle. Do you all have access to the module on Moodle? I enabled it this morning, so if you had tried it before, it wouldn't show up, but it will show up now. Okay, so on Moodle, on this, you will find all of the information that you could possibly need to know about the module. So it's split in weeks. Each of the weeks has dates, and everything is there already. So all of the lab sheets for the entire module are uploaded, and it goes all the way through the Easter break and everything that happens after that, and to the assessment week, which is the last week of the module. All right, so everything that you need to know is actually here, and most importantly, this paragraph. I will get to this paragraph in the end, because this is how the assessment for this module will work. I will go through my presentation slides and everything, and then I will explain everything in much more detail as well. So, to start with this, let's F11 this. Okay, so my office is in Anglesey building. It's office A202B. It's right next to a lab there. I'm almost never there. If I'm in the university, I will be in the lab. The lab that we're working in is A2.net. It's a specialized lab, it's our computer networks lab, okay? And the only modules that run in there are modules like this that require a specific kind of computer and resources. You all came in a bus? What? Oh, all right, I'll wait. I forgot what I was saying. So yeah, so the lab is a specialized kind of lab, all right, and you'll only have modules in there that actually need the computers that are in there. So if you need to find me, check the lab or send me an email. An email is the best way to basically get a reply from me as soon as possible. I check them all the time and everything, and especially this teaching block, I'm not as overloaded as the first teaching block, so I tend to reply faster than PB1. So, let's see, click on this, click on this. All right, the unit. So, we will have 3 hours in the lab with me per week, and you will also have a 1 hour of lecture as well. I don't know if the lectures will always be in this room. Timetables tend to change, so always check the location on your timetable to make sure you've come to the correct place for the lecture. The lectures run on Thursday morning, 9 to 12, or Thursday afternoon, 1 to 4. Please check, and please make sure that you come to the correct session as it shows up on your timetable. I cannot move any students around. I have this wonderful situation this year again, that the lab is overbooked. I can fit 96 students, and I seem to have a total of 102 students. Okay. This is because somebody in their wisdom decided to make this an optional module and not set any limits to as to how many people can choose this as an optional module. So I'm depending on 6 visa scammers to never show up. All right. If that doesn't happen, I have ways around this. Okay, so the only thing that you need to worry about is show up in your timetabled slot. Okay, don't come with your best friend in the other session. All right, it's okay if you don't see them for 3 hours, it's fine. All right. Now, What else do we need? The assessment for this module is by two assessment artifacts, as we call them. The first assessment artifact is the logbook, and the second one is the exam. The logbook is essentially a coursework. So I will explain all the details later on about this. It's very involved, and it means that you need to come to the lab every week. Unfortunate, I know. But, you know. What we will be working with is we will be working with CentOS, which is the free version of Red Hat Enterprise Linux. All right, so essentially it's the same operating system minus the hats and the logos, right? And it's the last year that I'm using this beloved version 7, because next year we're moving on to something else. It's fine. We'll have like a funeral for it and everything. Use it for a while. And we'll be using OpenNebula as our cloud solution. That will be on version 6. Okay. I will explain everything about OpenNebula in the next PDF that I have available today. Everything about the module is on Moodle. So if you have any questions about anything, check Moodle first, then send me an email and ask. All right. The lab. The lab is called A2.NET. Contrary to all of the other labs and locations and lecture theaters everywhere in the university that have numbers, because we're so cool, we decided not to name it A2.15 and 16 that it was in the past, but name it A2.NET specifically to make it harder for you to find it. Brilliant solution. It's on the Anglesey building. When you go up, you go left and left again, and it's a big thing at the end of the corridor. It has two doors. The first door that you will find doesn't open, just to mess with you even more. The second door is the one that you need in order to get in. All right. The lab itself, you will be in the lab for 3 hours per week, plus it has open access. On the door of the lab itself, I will have the timetable of the lab with all of the modules that are running in there. When there is no other module running in there, you can go and you can sit on your computer and work on it and put some extra time onto the computer so that you can finish your work, catch up, or even experiment with something else that you want. Even if there is a lab session in there, there is a good possibility that your particular computer might be empty. So what you can do, in one of the weeks, you can pass by the lab and see if your computer is empty. If your computer is empty, as long as you set your phone to silent and go in and be quiet, then the lecturers that is teaching there already will not mind, and you can sit and work on your computer and let them do their own labs and everything. All right. So generally, if your computer is free, you can work on it. The lab itself is open from 8 o'clock in the morning until 8 o'clock in the evening. So even after 5 or 6 o'clock, when other lab sessions are finished, you can still go to the lab and get a couple of hours of work in order to progress with your lab sets. During the consolidation week, which happens in the end of March, the lab is open. During Easter break, the 3 weeks that we don't have classes, the lab is open. Okay, so again, you can go in and work and do whatever you like. All right. The only problem that you might come upon is somebody else wanting to work on the same computer as you on open access. All right. In that case, I expect you to sort it out in a civilized manner and not fight over your computer. All right. Generally, if somebody else wants to use your computer, please don't stay more than an hour. Tell them, come back in an hour, let me quickly finish whatever I can within an hour, and then let them work. Okay? Pretty please, with sugar on top. One student per computer, so it's individual work, so you will all be assessed on what you will be doing on your computer yourself. Of course, you can get help. There will be a few of us in the lab to actually help you out if you get stuck with something. And of course, you can ask people around you, your friends, to help you. And there's lots of other ways that you can get help as well, and I will go into this as well later on. The computers and the user accounts are allocated. So it's very important that you come to the lab on the first week, next week. We will allocate a computer to you, and we will allocate a username to you as well. All right, so your usernames, I think for Thursday mornings will be VM3, and Thursday afternoons will be VM4. So when you go to your computer, there is 12 of those VM users, and each of the modules uses a different, or each of the lab sessions uses a different username. Okay, So once you work on your computer once, the first thing that you do, and it's in the lab sheet as well, is you change your password. All right. So once you change your password, nobody else can actually log into that computer with that username because they don't know the password. Fun fact, teaching block 1, I measured 28 students that forgot their password the second week. I would say that this is unacceptable, but then again, we all have TikTok brains and everything, so that's fine. So when you do change your password, set it to the same as the university password. Okay? Prayer time, quick. All right, so change your password as soon as you go to your computer. So that computer will be the same computer that you will always be working on with the same username that you will always be working with. Okay, that makes that particular username and computer yours for the rest of the teaching block, and nobody else can log in and mess with your computer. All right. The lab has no cleaners. Please don't eat in the lab. Please don't drink in the lab. The rule is you can bring anything you like in the lab as long as you can do this and still be dry after it. Yes? Good. So yeah, please tidy up, and please, this is a new feature that my students seem to have developed. Push your chairs back in under the desk before you go. I know that you're all very keen to go and you're just going to throw the chair around and run, but please. All right, good. Now, what else do we need? The logbook. So the most time-consuming of the two artifacts is the logbook. The logbook essentially will be a record of everything that you will be doing on the computer throughout the entire teaching block. All right, so the idea is I give you the theory, I give you lab sheets for that theory, you perform the tasks in order to complete the lab sheets to the best of your ability and get everything working. You document what you've done, so you take screenshots of configuration changes, screenshots of results of what you've done, and you include those screenshots in a logbook in the correct chronological order, pretty please. And most importantly, you need to explain under each of those screenshots what you've done and why you've done it this way. The idea of the logbook as an artifact is that I can see that you understand what's happening. So progress is pretty much a given. Okay, I do expect all of you to finish all of the lab sheets to some degree. All right, what I really want to see is I want to see that you understand what happened and that you've actually learned something from it. Okay, this is very important because you can get lots of help in the lab and outside the lab as well. All right, so the logbook must definitely include the reason why you've made whatever changes you made to your system. Okay, there is a specific structure to the logbook itself. You can follow it if you like. It simply makes my marking it easier. All right, but if you think that you don't like this format, then you can do whatever you like as long as the tasks are set in a correct chronological order, then it's fine by me. All right, the logbook itself must be a Google Doc. All right, the reason for this is because I want you to have a backup of this. I don't want you to lose your logbook because logbooks have been lost in the past because laptops have crashed or hard drives have crashed and so on. A Google Drive will not crash ever. All right. And next year when we switch to Microsoft, it will be OneDrive and I will hate myself, but never mind. All right, so you will need to create a Google Doc. You need to name it Cloud Computing and then your student number. So that should be the title of the document itself. And you can start with Lab 1, have a little bit of introduction. Today we're going to be setting up the computer so that we can install OpenNebula on it, for example. All right. And then you can have whatever methodology, everything that you've done in the lab, explain all of your work. And then in the end, if you like, you can write a little conclusion and say, yes, everything worked, I am the best, I understand everything, hooray. All right. So the logbook itself will need to be submitted at the end of the teaching block. So there is a submission inbox, and in fact I can show you all this, and I think I should now. So I need F11, and if you go to assessments, you will find that there is a submission inbox here. All right, so you need to go here and you need to upload your logbook. The logbook itself, when it exists as a Google Doc, it exists as a Google Doc. When you download it, you can download it as a doc or docx, and if you want, you can convert it into a PDF as well. I would prefer it if you convert it to a PDF in order to submit it into the Synbox. If you don't want to convert it, you can submit it as a docx. It's fine by me. Now, the way I mark the logbooks is very special for lots of very special reasons. The process to mark the logbooks is detailed in all of this. So there's two things you need to do in order to get the mark of the logbook. A, submit the logbook onto the submission inbox. B, show up in the last week of labs so that I can check your logbook and check your work on your computer. So you'll come into the lab, you will start all of your work, your virtual machines and everything, you will get your cloud running, and I will come to your computer and sit with you for 5 minutes and check that everything that you are detailing in the logbook actually exists in exactly the same way in your computer as well. I may or I may not ask you questions about this as well. The reason I do this is because I want to know that the work in your logbook is yours to begin with, all right, and B, that you understand what's happening in the logbook itself. Okay, so in order for me to verify that you know what's happening, that you've done the work and everything, it's because you get lots of help in the labs, and it's fine. Honestly, I don't mind if somebody sits with you one evening and does all of the labs for you. I really don't mind. I would prefer it if you struggled and tried to get everything working yourselves, which is what I want you to do, because otherwise you'll never really learn. All right, but if you are struggling, you can get help, and you can get somebody to help you out to various degrees with this. What I care about is that you understand what happened and that you can do it yourself again if you get asked to. And you will probably get asked to. You will get asked to set up or manage the cloud at some point in your life. Unless you decide, that networking is not for you and you're going to be a farmer or something. It's fine. I want to be a hotel manager, It's not working out for me. So, that's why we have that assessment in the last week in person. We call it a mini Viva. Viva is the oral exam in a PhD submission, basically. All right, so it's mini, like mini. All of the rules of engagement are there. So please read this before you come that day. And it's very important that you do both things, that you do come to the lab that day and that you do actually submit the logbook itself on Moodle. Lots of people come to the assessment. I've had 2 students in the previous semester that I gave 80% and then they forgot to submit the logbooks and got 40% because of a late submission. I mean, really. All right, so when the time comes, read this a couple of times. I know it's more than 140 characters, but please try to put up with it and read it to the end. All right. So, going back. Other than the logbook, we have the exam. The exam will happen at some time in the middle of May. All right, when the exam period actually happens. It's a computer-based test, so it will have multiple choice, multiple response, and all sorts of other types of questions like fill in the blank, for example, and so on. It will be 50 questions, and you will have 1 hour to answer them. Yes, there are a lot of questions. However, they are very quick questions. Okay, so everything in the exam will be from what we've done in the labs. So there will be no material in the exam that's not on Moodle. All right, so you can revise from your logbook essentially. The other important detail about this is that it's an open book exam, which means you cannot really bring your logbook to the exam because you'd have to print the 100 pages or whatever your logbook is, and we like trays. So you can bring a double-sided A4 size piece of paper. A4 size. People are laughing because I've had students come with 4 pages in the exam in January for another module. All right, and I need to have a talk with them at some point. One page, back and front, A4 size, yes? You can write whatever you like on it. You can write the story of your life. If you can make small enough letters, either printed or typed, you can include your entire logbook in there. Bring a magnifying glass and have at it. I don't care. All right. So, you can bring notes with you in the exam. They won't be of much use if you don't know what's happening. All right, because by the time you figure out what I'm looking for, time will have passed and it's a lot of questions to be digging around a piece of paper. All right, so other than the exam itself, what do we have? So we will be dealing with clouds. All right, so we will build a cloud solution, and so the whole thing starts with virtualization. So what is virtualization? It's the idea of taking computers, physical computers, and turning them into software. All right, so we have a specific infrastructure in place. We have a server, or we have a bunch of servers in a data center, and we can start virtual machines in there that they can do things for us. There are lots of benefits to this, and that's why it's been going on for about 10 years now. And the biggest thing is redundancy and failover. All right. So if you have one of those virtual machines and it's running and something goes wrong with it, somebody hacks it, or something goes wrong with the code that's running on it, if it fails, we can start up another one immediately that looks just like it, it's an exact copy of it, and it will run and will provide the service that the server was offering. Okay, that's why big websites don't just fall anymore. All right. If you ever go to Amazon UK and it's not working, I'll give you £1,000. All right. So the bigger the company, the bigger the infrastructure it depends on, the bigger the cloud provision it has, the bigger the percentage of uptime it will have. All right. We're now working on a downtime of 99.9999%, which means basically never. All right. So this is the number one feature of virtualization. There are other benefits to it as well. You can try out different servers and everything, and you can do pretty much whatever you like in test environments, test virtual machines, and it doesn't really matter. You can try different configurations, and it's something that you can configure, change your mind, delete it, start another one straight away. All right. So this is why it is so popular nowadays. So the purpose of this module is we will work with one specific cloud solution with OpenNebula. Because it's one of the best, I won't say one of the best out there because really you can't really compete with AWS, who can? But it is definitely the best free one. All right, and it offers all of the functionality and all of the features that most of the available cloud solutions out there offer, and you can train yourself and you can practice and you can learn things, technologies that are involved in this that you can work with. The most important concepts that we want to familiarize you with is what are the building blocks of a cloud? What do clouds actually consist of? So we need to get to the bottom of it and figure out how do you actually build a cloud, what do you need to get it to run, and then eventually what you can do with it. So in this module, we'll start with installing the cloud software itself. We'll do some initial configuration, and then we'll actually build some virtual machines into our cloud, and then we'll play around and see what we can actually do with them. And then eventually, the second half or towards the end of the module, you will have to build an as complete cloud solution as possible for your own little network. So each of the servers, each of the computers in the lab will host their own cloud. And that's why it's a specialized lab, because it's very new Xeon CPUs with 64 gigabytes of RAM and 4 terabytes of NVMe, which allow you to start lots of those virtual machines and run them. Okay. Okay, I skipped a few slides, that's fine. So cloud computing, the definition of it, all right, is the on-demand availability of computer system resources, especially data storage and computing power, without direct active management by the user. So essentially it means that you as a small company, can have an AWS subscription, and you can have some resources in that AWS cloud, or in any cloud solution really, and you can use them without actually having to manage anything, right? So you go to a company, you tell them, look, I need to have a server that is a web server for my products, and I need to be able to create a new website for it and upload it and use it, and I never want it to fail. So the most basic functionality that you can rent out from a cloud, from a public cloud, is something like this, a service that you want your company to be providing to the rest of the world. Because the alternative would be what? You build a web server in the back of your office, and you have an internet connection, and that web server runs all the time, and then if it fails, what happens? You need to call somebody to fix it, or you need to hire a system administrator to make sure that your web server never fails. All right, because your web server is your store probably. It's your means to make an income. So you want it to be running all the time, and you want it to be running as cheaply as possible and as easily as possible. So instead of paying some guy £2,000 a month to make sure that the thing never breaks and it still will, you pay a subscription to some company, and then they host and they run everything for you, and then that's it. On a bigger scale, you can have a company that's a medium-sized company. They can build their own cloud solution, and they can provide the resources to the people that are using them. Let's say, for example, it's a university. Okay, let's say that we have students and they want to use some network simulation software. All right, you don't want them to have to come to the lab every time. You can give them remote access to your cloud that has virtual machines that run the software inside them. They can connect on a web interface and do that from wherever they are on the world. Okay, so this would be another scenario of you actually using cloud that you run and you manage yourself and so on. So, why is it useful? Efficiency, flexibility, and strategic edge. So, the gist of it is it makes your life easier and it saves you a lot of money. All right, because you don't have to manage everything yourself. You just rent out whatever resources you want, be it storage space or virtual machines that run some specific service or some software that runs on them and so on. The idea is that you are outsourcing your computing needs. All you need to have in your company or in university or whatever is a weak laptop or desktop that has maybe a web browser that can connect to whatever system you're using on the cloud, and then you can use it, and that's it. And not even that, you can have a bring your own device policy, and the people that work for you can bring their own laptops or their own PDAs or tablets or whatever, and as long as they have a browser, they can connect to it and they can work. And in fact, they don't actually have to come to work. They can be roaming salesmen that travel all around the country or the world, and they can connect to the system and use it wherever they are, and it doesn't really matter. Okay, so it solves lots of problems of you. It solves the main issue of you having to provide the IT infrastructure for your employees so that they work. All right. Now, in the lab itself, what we'll be doing is we'll have the intro, which is this week. You have design and installation considerations, OS and environment installation. So next week, when you come into the lab, you will basically create the environment that you need in order to deploy your cloud. Ironically, it's a virtual machine. All right. So you will start with downloading or actually extracting a virtual machine from your hard drive. You start that virtual machine, you run it, because then you will have root permissions in that virtual machine, because you need to be able to log in as user root to make changes. And then in that, you will install your cloud software, and in that, you will start the virtual machines inside the cloud. So this is a lovely thing that we call nested virtualization. So VMs inside VMs inside VMs. It's like a Russian babushka doll, Fun. Anyway, so that, and then after that, we'll have building first virtual machine, exploring the interface, the web interface that lets you manage the cloud itself. Then we'll do a little bit of networking, because networking in the cloud is one of the most important features in it. So we will be using something called OVS, OpenVS Switch. So we will explore what kinds of network connections we can have in order to provide our virtual machines in the cloud with connectivity to the outside world. And then eventually by the end, the last lab sheet is that you build your own cloud. Essentially, you need to configure your cloud in such a way to provide various services for a small company, a scenario, you can do whatever scenario you want, and actually build, configure, manage all of your users, the services that you want to provide in there, and all that. Okay, so this is the schedule that we will follow in the lab itself. If you need to read up about anything, the most important resource there is actually the Open Nebula manual. Okay, because everything that we will do is actually there. My lab sheets are based on the manual itself. Okay, and hands up if you have never used Linux before in your life. It's not a bad thing, I just want to know. All right, that's promising. Good. So you will need that book, which you can find in PDF as well. Yeah, and I think you can find it in the library as well. So because we'll be working on Linux, you do need to have a basic understanding of how the operating system works. Okay, it's not Windows, everything is completely, absolutely different, other than the fact that there's a mouse that you can move about. Okay, so you will need to familiarize yourself with the basic commands and everything. What I can do is, I can send you the lab sheet that I have for my first year students that install and familiarize themselves with the operating system itself. So you can play around with the commands a little bit and try to familiarize yourselves and figure out what is what. Another way you can learn the operating system, because it is Red Hat based, we are now a Red Hat Academy. Okay, so if you were here in the previous teaching block, you will have received an annoying email from me saying that, yay, we're now Red Hat. So this means that we have free access to all of their teaching, all of their learning materials about Red Hat. So you can do the certifications that Red Hat offers and everything else. Okay, so if you do want to play around with this, you can actually send me an email and you can try, we can try to set this up. If you have been here in teaching block 1, then you will have automatically been added to the courses and you should be able to log in and so on. If you are January intake students, please send me an email and I will set it up for you so that you can log in, because there are lots of learning modules in there that you can follow and learn in great detail about the operating system. Okay. And that's that for this one. Do you have any questions about this so far? Okay. So then, what do I have? So the first lab sheet will be, let me have a quick check. Let me do the lab sheet first, I think it will be better. So when we come into the lab, you will all sit down on your computers, decide which computer you want to use, make sure you find one that's away from the window so that's whatever you like. You will be given a username, you will be given a password to log in at the first time. The first thing that you need to do is change that password into something. The instructions are there. You just need the passwd command to do that. And after that, you will need to go onto a folder that's called global in the system and find a zipped file that's called tb2 Prometheus and extract it. So Prometheus is the name of the virtual machine that I'm using. Lately, there is another Prometheus technology that somebody stole from me, and they call it something else. It's not the same thing, but I got it first, yeah. Because I'm Greek and he gave the fire to people, and then it's like ancient Greek mythology. It's fine. It's like me giving you the knowledge of, yeah, all right. Anyway, so yes, it's called Prometheus. Let's live with it. Learn how to spell it, please. You will extract the virtual machine. The virtual machine is pre-built, so the operating system is inside it, so you don't need to install it. Okay, you just need to run it, and you just need to log in, and you will need to log in as user root. You will always need to log in as user root, because 99% of the tasks that you will be performing will be tasks that require permissions for you to be able to do everything. Okay, it will require administrative permissions. So you log in, and then you can basically start with the installation. The other thing that you'll have to do is you'll have to set up the networking for it. Okay, because it will have an IP address, but it will not work because you all need to have your own IP address. Each of your computers in the lab has its own name and its own IP address. They're all on subnet 28, so everything starts with 148.197 because that class B network, all of it belongs to the university. And then subnet 28 is what we use in the lab. And then your computers are from 1 to 48 in there. Your virtual machines, your Prometheus virtual machines, will need to have an IP address of whatever your computer is plus 100. Sorry, plus 50. And I need to change that. Good. All right. Okay. So if you're sitting on computer 1, your Prometheus will need to be 51. All right. So you need to set up the IP address like that and make update the lab sheet. And once you do that, you should have full internet access and you can get on with the installation. So the first thing that we'll need to install will be the front end. So the program that actually manages the cloud itself. Okay. So in order to do this, we will need to create what we call a repository. All right. So we need to tell the operating system where to actually get the installation files from. So we create the repo file. It looks like this. You save it in this location, and then you run the yum make cache and install Apple release commands so that the operating system reads the new repo file that you created and it adds it to its list of places to check when you're trying to download something. And then you try to download something. So yum install OpenNebula server and Sandstone, and then Gate and Flow should go online, fetch all of the files that you need, and install them for you, and you don't actually need to do anything about it. Okay. Once that happens, you can start, and before you start OpenNebula up, the admin account of OpenNebula of the system is called OneAdmin. One as in OpenNebula. All right. That's why everything is called one something in there. All right. So OneAdmin as a user needs to have a password. Before you run the service, you can change this password simply by changing the contents of a file on the system. Okay, it's in the user's home directory. It's called OneAuth for authentication, and you set the password to localhost 1. So if you type this echo command, it will basically put OneAdmin localhost 1 into that file, and that's it. So once you do that, you can then edit the server configuration file itself. We will need to disable the endpoint, the FireEdge system on it. It's just another management console for our cloud that we will not use, so we don't need it to start. And then we can actually start OpenNebula and OpenNebula Sandstone. OpenNebula is the program itself that runs the cloud, and OpenNebula Sandstone is the web interface, the web page that you go to in order to see everything that you want to see about it. All right. Once you do that, you can verify that everything works by opening a terminal and typing one user show. So this is in a command line because OpenNebula as a cloud doesn't actually need Sandstone to run. It can run on a terminal, just like all other services in Linux. And that's one of the benefits of Linux over Windows. Well, Windows copied them and you can do an installation of Windows without a graphical environment anymore. It's fine. I'm jealous of it. So you can have a server that doesn't have a graphical user interface at all. You have to be really hardcore and really geeky to do this. I actually had a student that attempted this last year. Failed miserably, but it's fine. Worth a shot, you know. So yes, if you do one user show and it says you, yes, we have a user, his ID is 0 and he's called OneAdmin, hooray, it means that the thing is working. All right. And the second test for it is to actually go onto localhost 9869 because that's the port in which your Sandstone web server actually runs. Right, and you should be able to see the Sandstone welcoming page and you should be able to log in as user OneAdmin and see your system, what it looks like. On the next page, there is some locations of specific files of where everything is. You don't need to do anything about all this. This is just there for your information and you can refer back to it later on if you actually need to find where the data stores are actually stored on the system and so on. And then we can install the KVM node component. So the virtual machines inside OpenNebula are based on the KVM hypervisor. So in order to start a virtual machine, you need to have an engine, you need to have a program that runs virtual machines. Okay, programs that do this are KVM, for example. You can have VMware, you can have VirtualBox. There are lots of different technologies that can start virtual machines. By default, OpenNebula depends on KVM. So KVM needs to be running on your system. And in order to do this, all we need to do is install it and then start the virtualization service onto Linux. libvirtd it's called. Right. So once you do that, it means that you have given your system the capability to run virtual machines, and you can move on to the next bit that's required, which is the passwordless SSH. So all of the different various components in the cloud itself need to be able to communicate with all of the virtual machines that you'll build and all of their services without any input from the user. So one admin as a user needs to be able to SSH onto any of the virtual machines and query them for information, and that's why we need to be able to SSH passwordlessly. In order to do that, we turn off strict host key checking and we set a host file to nothing. So that will allow the one admin user to log in with SSH to all other computers in the cloud without asking for a password itself. We change the permissions on it, and then we can check it by SSHing localhost, and it should just log in without asking you for a password. And that will be the end of the lab sheet itself. Okay. I also have, but I am running out of time, so I will just explain the basics. This. So the way that OpenNebula works, its basic structure is this. And this applies to most cloud solutions out there as well. This is the basic architecture for most cloud solutions that are available out there. So you have your front end, which is the software that manages everything. Okay. You then have your hosts, which are the computers, the servers that can run virtual machines with the use of KVM in our case. We then have the data stores, which is where all of the data is stored, all of the storage space, our hard drive space for the cloud. And then we have two different types of networks. We have the service network that makes everything communicate with each other, and we have the VM networks, which allow all of the virtual machines that we've built into our cloud to communicate either between themselves or with the outside world. Now, in this particular diagram, every component can be on different computers. Okay, when we get into the lab, I will show you if you like, because we do have a little cloud of our own. Right, so I will show you what it actually looks like. You have a rack, you have lots of servers that give us their CPU and memory, and they are the hosts because they run the virtual machines. We have a storage server that has about 30 terabytes of space, I think, or 60 maybe, I think 60. And it has all of the hard drive space that we'll need, and it's separate to them. And then we have 3 switches that connect all of those hosts between them and with the server. So one of those machines runs OpenNebula, so it runs the front end, and the others are there just to give us the ability to start virtual machines. And all of these communicate with each other with the switch. Now, in our particular scenario in the lab, all of this will be on the same computer. In fact, all of this will be inside your Prometheus virtual machine. So your Prometheus VM will be where you are installing the front end, as we saw on the lab sheet. It will be the one providing the storage space for our data stores. It has 200 gigabytes of space. It will be the one that's providing us the ability to run virtual machines because we installed OpenNebula Node KVM onto it, so it can run VMs itself. And it will be the one that will provide us with a network connectivity to the outside world, so through your physical computer, through the lab and outside, and to the virtual machines themselves once we install Open vSwitch, that will give us the capability to create virtual network cards inside the cloud that will basically help all of the virtual machines communicate with each other and with the outside world. Okay, so all of this infrastructure, you will be creating it on the same computer, and in fact inside a virtual machine itself. Okay, so the components that are needed, the most basic components that are needed for all of this to run are these. What I want you to do before you come to the lab next week is I want you to have a look at this document, all right, and read everything inside it. Yes, there is a little bit of business mumbo jumbo that you don't really care about, like all of the extra features that the cloud solution itself can provide and so on. But I want you to understand the mechanism, what the components actually are. So when you are actually doing the lab sheet, you understand which part of the network diagram you're actually building and you're actually working towards. Okay. So the next lecture for this is on Thursday afternoon, 4 o'clock, which means that it will be after the labs. Okay. So next week when we do the labs, we will be working on the first lab sheet, which is OpenNebula setup, and then I will explain the second lab sheet after that, which will be VMware creation, which is what you will do for the week after. So the lectures themselves in material will be 1 week ahead of what we're doing in the lab, because I want you to know the theory before you actually come into the lab, and it also gives you some time to read the lab sheet, and if you have any questions, as soon as you come into the lab, you can ask me and say, Vas, what's going on, what does this actually mean? Okay, if you think that you understand this and you like it and you got it and you don't really have questions and you're strong with it, you can move forward. Okay, if you can go into the lab, sit on the computer for 2 days and finish all of the labs. It's fine. All right. I actually allow students, if they want, to come and have the logbook submission mini Viva earlier. Okay, so I've had students that wanted to go home for Christmas and they did the assessment 1 week before. For me, it doesn't matter. If you are happy with the work, with the way that you're progressing and everything, you can do whatever you like. Okay, progress-wise, I'm not monitoring it every week. As long as you complete all of the lab sheet by the end of the semester, it's fine by me. On the other hand, if you are struggling and you are falling behind, don't panic. It doesn't mean that you need to finish 1 lab sheet per week. You can progress at your own pace as long as you eventually catch up, and the Easter break is a very good opportunity for this, and have everything done by the end of the lab itself. In order to do this, especially if you're struggling, and this is where I get to the point about the help that I was talking about, you can come into the lab and get help in the lab. I have teaching assistants. I have students that were here in the previous year and they're doing their dissertations now, so they know everything about it and they help me out in the labs. The other thing that those students can do is they can offer one-to-one sessions to help out outside the labs. Okay, so I will send you all an email so you will know their emails and everything, and you'll see them in the class. Okay, it's mostly Jiten and Shaf and TJ that will help out this semester. Okay, so if you need to get some help from them, you can send them an email and you can arrange a time and sit with them and they will help you out. Of course, you will need to pay them. Yes? Nobody works for free. Well, they work for me for free this semester. Yeah, never mind, anyway. So yes, there's something like £20 an hour or whatever. Okay, I've had lots of students that had lots of results from this last semester. My favorite one was a first-year student that in the first 3-4 weeks was really struggling, and when it came to the assessment, I actually gave him 100% in the logbook. But that was after I asked him about 12 questions about everything, and he knew everything perfectly. Okay, so he went from 0 to hero because he had lots of sessions with Jiten. Obviously, he was loaded, but I mean, it's fine. You don't have to overdo it, So yes, you can get help outside the labs as well. All right, and the people that I have are quite good at it, and I'll send you more details about it over an email probably next week. Okay, I think that's everything. If I forgot everything, something else, you know where to find me. So I will stop the recording here. Jesus, 15 minutes.